In this tiny review, I just want to take a look at the introduction that we've already had to ionic compounds. It's been several days since I talked to you about that stuff, so let's just take a look at what we learned to refresh our memories for 5 minutes. So the first thing about ionic compounds is that they don't follow the same rules as covalent compounds. So important. Okay, no prefixes, no more mono, di, tri, tetra. You don't need to worry about that anymore. Also, with covalent, it was nonmetals only. Well, now with ionic, it's going to be a metal donating to a nonmetal. Okay, and a reminder that on our periodic table, this is the dividing line right here. Up in the corner on the upper right, that's the nonmetals, and everything else is metal. So typically we're going to have a metal and a nonmetal, okay, or more than one nonmetal in a ionic compound. Now there is one thing you should note is that there is this clump of atoms, NH4, that will donate one electron to get a positive one charge, and that's called ammonium. Okay, that's an important exception. Nitrogen and hydrogen are nonmetals, but when you put them together as NH4, they pretend to be a metal. Okay, so what you're looking for in an ionic compound is, does the name or the formula start with a metal or NH4? If it doesn't start with one of those two things, then you need to stop. It's covalent. You should use the prefixes then. On the other hand, if it does start with a metal or ammonium, then all you got to do is write the names or the symbols of the elements, just like you would with covalent. You go find them on the periodic table, write down the names. You're going to change the endings, just like covalent. And a lot of the time, you're going to stick with "ide," just like we're used to. That's perfect for when the anion, the second part of the formula, is only one element. And you can see that on our special class periodic table here of ions, that when you look at any one of these ions, they all end with "ide." Okay, these are all the ones that are a single element: oxide, fluoride, chloride, etc. Now sometimes you end up with an anion that's a clump of several different atoms. That's a chunk of atoms. That's called a polyatomic ion. Poly means many, atomic, atoms. So polyatomic is an ion that's made out of several different atoms. And again, you got to look those up. We've got a whole table full of them here, and they all have their own names. Okay. Now most of them don't end with "ide" anymore. A lot of these end with "ate," like acetate, arsenate, bicarbonate. Some of them end with "ite," ite, bisulfite, chlorite, okay, hypochlorite. Further still, some of them in here do end with "ide." So just because it ends with "ide" doesn't mean that it's only one element. Could be polyatomic, like cyanide is CN. But for the most part, it's going to be that ATE, ITE endings. And if you see an 8 or an ite, then it's guaranteed to be polyatomic, right? None of the single ones do that. Last thing you need to do is just check if the cation is a transition metal. If it is, there might be two different choice of charges, right? Like iron could donate 2 or 3 electrons. Could be iron 2, could be iron 3. If you have more than one choice, then you need a Roman numeral inside of the name. If there isn't more than one choice of charge, like here rhodium is only 3+, then you don't need to worry about that Roman numeral. Let's just try a couple of new examples to refresh our memory. So, Be. Is that a metal? That's the first question we need to ask always. Well, beryllium is over here when you look it up. I can see it peeking out on the left side of my notes here. That is a metal. So now I get to write the names. Beryllium. And F, that is a single element. And you can see over to the right side of my notes, that's called fluoride. Feels like we're done, but we should do our quick check for a transition metal. Is beryllium a transition metal? Is there more than one choice of charge? And it isn't. It's in the alkali metals. It's only 2+. So we're done. Beryllium fluoride. No prefixes. Easy peasy lemon squeezy. ZnCl2. This time I'll move my notes over, and just peeking out there in group 12 you can see Zn is zinc. That is a metal, so we get to keep going with our rules here. This is not covalent. I'll write down zinc. Cl is chloride, because it's a single element anion. And now zinc is a transition metal, but only one charge. So I don't need to put the Roman numeral in there because it's only 2+. And we're done again. Zinc chloride. Finally, NaCN. Is Na a metal? That one's hiding over in the alkali metals in group 1. I went and looked for it. Here it is. Okay. So Na is a metal, so this is ionic. I can keep using these rules. I'm going to write down the name sodium. And now we've got Cn here. Cn, that's two different elements put together, carbon and nitrogen. And that means this anion is polyatomic. So I have to go look for Cn on my periodic table back here. And that one turns out to be right in the middle here, Cn. And the name of that is cyanide. Yes, this is the cyanide from the poisons. So we just write the name of that thing, cyanide. Double check again, is sodium a transition metal? Is there more than one charge? No, there isn't. It's in the alkali metals, +1 only, so I don't need a Roman numeral for this one, which means we are done. This is sodium cyanide. So, there's a quick review. Hope it makes sense. We'll see you in the next video.